This video involves what is known as families of functions. Now, what we're going to specifically be focusing on is this idea of transformations, which we've done in geometry. Remember, that's moving an object up, down, right, left, flipping it over the x-axis, flipping it over the y-axis, or flipping it over in geometry. We did y equals x, stretching it, compressing it, which in geometry we called a dilation. So we're going to be doing these for functions, all right? So what I'm going to first identify here are what are known as parent functions. And every function that we're going to study in Algebra 2 can be traced back to a parent function. For example, the parent for a linear function is y equals x. All right? For an absolute value function, it's y equals the absolute value of x. For a quadratic means it is degree 2, so it would be y equals x squared. A square root, y equals the square root of x. These again are all what we're going to refer to as parents in Algebra 2. Now, just to go a little bit further, we definitely will not be talking about any of these next four in this prep work, but definitely you'll be studying them most of the year in Algebra 2, and that would be the cubic function, y equals x cubed, the cube root function, which is y equals the third root of x. That 3 is kind of up on the kickstand of the radical. An exponential function, which would be y equals a to the x, and that a, we're going to learn about its importance. And then a logarithmic function, which would be y equals the log of x. All right? So with these parent functions, we have to be able to do what are called transformations. Transformations mean moving an object up, down, left, right, or flipping it over. Okay? Every transformation goes back to the parent. What did you do to the parent to get this? All right? Now, if you're just moving it up, down, left, or right, that's called a translation. Okay? A reflection is when we flip it. All right? So a reflection, typically across x-axis, y-axis, or y equals x, all right? You're reflecting points that are on that particular graph. Okay? So I kind of condensed this a little bit to some general reflection rules. When you reflect over the y-axis, x changes. When you reflect over the x-axis, y changes. And then what I did was I rewrote these in a function form. So f of x, when you reflect it over y, becomes f of the opposite of x. Or in other words, you're going to hear me say this, I'm going to put a negative inside the function. All right? Or if I have f of x and I reflect it over the x-axis, I'm going to put a negative in front of the function. Now, we also have these things that are called vertical stretches and vertical compressions. All right? The key for vertical stretches and compressions is simply this. It's a stretch when you're looking at a function, a times a f of x. That a value tells the story. That number in front tells the story. If a is greater than 1, it's a stretch. If a is between 0 and 1, it's a compression. All right? If a is negative, it's not a stretch or a compression. That negative doesn't have any impact. That goes back to our reflection rules. That negative in front would tell us I reflected over the x-axis. All right? So a is always going to be a positive value. All right? Here's a little summary that you would get in a book of transformations. Vertical translations, remember that's up and down. Horizontal, left or right. Vertical stretch and compress. And reflecting over x, reflecting over y. So the next thing that I did right here, and you might want to freeze this and jot this down, is these are my rules. These are the rules that I have followed forever and I really have a good understanding of transformations of functions. If you add outside, that's moving it up. Subtract outside, down. Add inside the parent, left. Subtract inside means right. Those are the two that are a little bit weird. Add inside, left. Subtract inside, right. A negative in front, reflect over x. A negative inside, reflect over y. If you multiply by something greater than 1, it's a stretch. If you multiply by something between 0 and 1, it's a compression. We will be doing all this stuff right at the beginning of Algebra 2 next year. All right, so let's look at some examples. How does each function relate to the parent? So the first thing, you always want to identify what the parent is. In this case, it's y equals x. Now, what does y equals x minus 3 tell us? Well, that minus 3 is telling us it is down 3. Minus 3 on the outside tells me down 3. And the second one, if I'm adding 1.5, that means I'm moving it up 1.5 units. So when I move it up or down is going to impact the y value of the parent. Okay? All right, so another thing that they may do is to say, take a table and adjust it. So in this first one, for instance, they want us to move it 3 units up. So I'm going to take my f of x, my y values, and add 3 to them. When I do that, let's see what we get. Instead of the point negative 2, 3, we have the point negative 2, 6. We have the point 0, 4. We have the point 1, add 3 to negative 2, that gives me 1. We have the point 3, add 3 to negative 2, that gives me 2. So I have all these points, negative 2, 6, 0, 4, 1, 1, and 3, 2, which was a translation of that original function 3 units up. If I go 1 unit down, symbolically that would be saying take the function and go down 1. That's going to change our f of x or y values. So 1 becomes 0, 0 becomes negative 1. And again, remember, each one of these are still points. This will be the point 0, negative 1. The next one will be the point 2, negative 5. And 3, 1. All right? So that takes care of ups and downs. All right? What if I want to take and do a vertical translation of this function? So we're still going vertical, up and down. How is it going to look in compared to the function? Well, I know that down 2/3 means I'm going to subtract 2/3. I would write this as y equals f of x minus 2/3. If I want to go 4 up, I would have y equals f of x, the parent, and then I'm going to add 4 outside the parent. And that's it. That's it. All right, so what now if we change over to horizontals? Horizontal, remember, we're going to go right or left. I've got to identify my parent. There's my parent. F of x is equal to x squared. I know that left means add inside. Right means subtract inside. Those are my rules, right? So what is this first one doing right here? I am subtracting 4 inside the parent. Remember the parent was x squared. We replace the x with x minus 4. So subtracting 4 inside means right 4. Adding 3 inside really means left 3. And I want to pull up my graphing calculator just to kind of show you guys this. All right, on my graphing calculator, if I look at this first graph, this is the parent. This is y equals x squared. Now, if I go back to my y equals, and I turn on the x minus 4 squared, all right, turn that one on, and then graph it. Here's our parent still. We said that that's going to move it right, and you can see that red graph moved the blue graph 4 units to the right. 4 units to the right. Okay? Now, the other one was plus 3 inside. And we said that that moved it left 3. So let me turn that on so you can visually see it. All right, remember from the blue, if we move it 3 to the left, I get that black graph. So hopefully that gives you guys a little visual there to help you out with this right and left movement. Okay, let's take a look at this next question now. It says the graph of this function. Now, this is a weird function. It doesn't have a parent. So sometimes they're just going to say, here's a graph, we're going to call it f of x, okay? We need to make a table of values for f of x and f of x plus 3. So here's the way we want to do it. The first thing we want to do is identify x's. For the x's that we know, what is the f of x? And then what's going to happen if I move it f of x plus 3, and notice the plus 3 is on the inside, so that's saying moving it left 3. Who's going to change if we move it left? Well, hopefully you recognize, whoop, sorry about that, wrong flavor. The x is going to be what changes now. If I move it left 3, the x value changes. Okay? All right, so let's take a look here. If I have these particular values, I have an x value of 2, and for that x value of 2, the y value, or f of x, is 0. Okay? I have a y value here, or sorry, an x value here at 3, and at 3, the y value is at 2. At 4, we're kind of in between, so I'm going to skip that. At 5, I would say we're at 3.5. So I'm going to say 5, 3.5. And at 6, we're back down to 0. Okay. If I'm going to move this left 3, remember, these are the numbers that are going to change. All right? So I would have -1, 0 as my next point. So what happened was this point 2, 0 moved over here to the left to -1, 0. All right? So if I go left 3 on this next one, I'm at 0, which would give me the point 0, 2. I would be at left 3 here would put me at 2, gives me the point 2, 3.5. And if I go left 3 from 6, I'm at 3, or I have the point 30. I know that this can kind of start to get a little bit confusing. That's why it's so important to recognize what that really says. It is saying move the function left 3. When I move it left, x has to change. All right? So now let's talk about some reflections. If I'm reflecting, they're going to ask me to reflect over a y or an x axis. Eventually, we're going to get to reflecting over the line y equals x. All right. When we reflect over x, these again are my rules that I told you guys to copy down. When you reflect over x, a negative in front. When you reflect over y, a negative inside. All right. So this first one, they want us to take the parent. This is our parent. And they want us to reflect it over the y-axis. That's a negative inside. So I know that f of negative x is 3 times negative x. Or if I clean this up, I get negative 3x. So you can kind of see it. For that particular function, whether I flip it over x or y, that negative still comes out in front. Okay? But this is our final answer. Now, what about this one? We're going to reflect over x. Here's the function we're starting with. This is how they want us to reflect it. So that's negative f of x, which means I'm going to take a negative and distribute it into the function. So my result here would be negative 2x plus 4. And that is the equation reflected across the x-axis. Okay? All right, so let's take a look at this. What if they give us this parent y equals x, and they say, what's it going to look like if we do a vertical stretch of 4? Very simply, that means put a 4 in front. So we're talking about stretches and compressions now. That's our A value. What if they want me to do a vertical compression by a factor of 1/2? Well, that's simply going to be y equals 1/2 x. Done. Okay? All right. For this next exercise, they give us this parent. F of x is equal to 4x. They want us to go up 5 and reflect over x. All right? So the first thing that I want to do here is say, okay, I know that f of x is equal to 4x. If I go up 5, then this becomes f of x is equal to 4x plus 5. Notice the plus 5 is outside. Now, if I reflect over x, that's a negative in front. So then f of x would be negative 4x minus 5. I distributed the negative there. This is my final result. Now, I could have, in hindsight, I could have thought of it this way too. This is really saying take f of x and add 5. And this is really saying take a negative of f of x plus 5. All right, let's try this one. What if I take that same parent, f of x is equal to 4x, and I want to vertically compress it by a factor of 1/8. Okay, so if I vertically compress it, then this is going to become 1/8 times 4x. Now I'm going to clean that up. That's really now 1/2 x. All right, and then they say they want me to reflect it over y. Well, reflecting it over y means I have 1/2 times negative x, which would be negative 1/2 x. And this is my end result function. All right, last thing I want to do here, and these can get a little bit tricky here. They want to know, how do you go from f of x to g of x? All right, so I'm going to start with f of x, and that's x over 2. All right, the first thing that I want to do is I want to get that 4 into the mix from g of x. So what I'm going to do is I'm going to go up 4. So my new function becomes x over 2 plus 4. All right. The next thing that I want to do is I want to, actually, let's do it this way. If I don't like doing that, I don't like doing that. So let's see. If we take the x over 2 here, the first thing that I want to do is I want to find out this negative 2x. So if I do negative 2x, that means I'm going to flip over x-axis, and I'm going to stretch 4. All right, so flip over x and stretch 4 means we have negative 4 times x over 2, which would give us negative 2x. Okay, we're on the right path now. Then I want to do the up 4, and that would leave me with negative 2x plus 4. So what did I do? I flipped over x, I stretched 4, and then I went up 4. Okay, let's try this next one here. All right, so I'm going to start with f of x is equal to 3x. All right, I'm going to go ahead and compress by a factor of 1/4. Now, what does that do? That gives me 3x becomes 1/4 times 3x, which would be 3/4 x. Okay, I got that part. Now I want to go minus 2, but notice how it's inside the parenthesis. All right, so I'm thinking what that's saying is right 2, and that right 2 would take me to 3/4 x minus 2. All right, so what did I do? I compressed by a fourth, and then I went right to. All right. Don't be afraid to look at those. Help me solve this on some of these questions. All right. Do the best that you can. Let me know if you guys have any questions.